All right, so this is homework 3, and we're going to just kind of work our way through this. So again, we're going to focus on giving out given, required, and solution, using a straight edge, etc., etc., etc. So a bartender wishes to make a fancy drink with 5 different layers of fluid, each a different color. They usually have to use a fancy little spoon to do this, but, I've been placed, actually, I don't think I've ever seen one of these. People have told me about these things. The fluids have different specific gravities, okay? And if each layer is 1 inch thick, what is the pressure in the middle of the second layer from the bottom? Report your answer in gauge and absolute pressure. Okay, note I have trouble spelling the word gauge, so it's going to have different things whenever we look at it. Okay, so we're going to go over here, and because I require graph paper, so we're going to go ahead and use that. So I'm going to do given. Okay, well, what are we given? I like to do a given as a drawing just because it somehow seems easier to me. It doesn't have to be. Although if given a drawing, you have to do the drawing, right? So here, so this bartender has a glass of some sort. I'm going to use a straight edge here because I require it of you. And also, I want to make the point that it doesn't take that long to use a straight edge. A lot of you guys avoid it, and I assume it's just because this seems like a ton of work. But I want to make the point that it's not that much work. Okay, of course it stinks when you're on a computer and it... All right, now, I don't usually use straight edge for liquid surfaces because they're not straight, right? They are free surfaces. They can move around and whatnot. Okay, so these are our 5 layers of fluid. However, the glass itself should be straight. Okay, so this top one is a free surface. Okay, and each one of these is 1 inch in depth or whatever you want to call it. Okay, yeah, depth I think would be the correct word here. So we're going to go like this. All right, and we're just going to kind of label those. Okay, and I think you'll see that if you pay attention to this, it doesn't take that long to do these, to do a drawing. Okay, even with the straight edge, and even if we're doing a good job here. Okay, now each of these has a different specific gravity. S equals 1.1, S equals 1. So that layer could be water. S equals 0.9, S equals 0.8, and S equals 0.7. Okay, so what we want to know is we want to know the pressure right here. Some of you gave that point a name. It doesn't really need a name. But, there it is. So it's about like that. I will note, if none of you guys have ever thought about this, you know how, like, if you look at these little things right here, we typically draw it like, okay, here's the thing coming in, and I'll draw this little tick mark right there. What is that the little diagonal tick mark? Well, that actually is going into the board, and it's actually referencing the third axis. This is an aside, obviously. But this would be as if we had, so if we had our x, in fluids, typically it's going to be like this. Like this is going to be x, this is going to be z, and then this is the y direction right here. Okay, that's the y direction. So this little tick mark here is in the y direction. Okay, so it's kind of referencing that other axis. Okay, just something to consider. Okay, that's what those little side diagonal marks are. Okay, anyway, so again, even with that little aside that I just threw in my discussion at the beginning of the problem, we're 3 minutes and 45 seconds into this. That picture probably took me, 1.5 minutes to make? Okay, so please just draw things. If I give you a drawing, just, copy it. Okay, it's not going to hurt you at all. Okay, what do we want to know? Well, the requirement is that we want to know the pressure at this point. Maybe we'll call that point, let's call it A, right? So we'll say the pressure at point A equals what in gauge and absolute, okay? Okay, so that's 2 things we need. Okay, so solution. Okay, so what we're going to do is I'm going to start up here at the surface. Here, I'll do this in kind of blue or something. Okay, I'm going to start here, okay, where the pressure is the atmospheric pressure. And I'm going to keep track of how much the pressure changes as I move downward through the fluid. So if I'm moving downward through the fluid, the pressure is increasing, so I'm going to go plus. And I go down some amount in fluid 1, so I'm going to call this fluid 1, 2, 3, 4, 5. Okay, so let's zoom in. There's no reason to have all that other stuff. Okay, so gamma 1 times the depth 1. Okay, and then I'm going to go from there to there. So now I got gamma 2, depth 2. Okay, now I'm going to go down here, plus gamma 3, H3. That's how much the pressure increases as I move downwards. And then it's going to increase just a little bit more, plus gamma 4, H4. Okay, and that gives me the pressure at A. Okay, so, and that's how we set this problem up. Okay, moving downwards through the fluid, the pressure increases. Moving upward, the pressure decreases. So now we just have to do some algebra here. Okay, and I'm going to leave PATM as is because that's going to make things a lot easier. So I'm going to do PATM plus gamma 1. Well, that's going to be S1 times the gamma of water, H1. Plus gamma 2. Well, that's S2 times the gamma of water, H2. Plus gamma 3. Well, that's S3 times the gamma of water times H3. And gamma 4. That's S4 times the gamma of water times H4 equals PA. I'm going to change the order of this equation. I'm going to kind of flip the sides because I'm going to want PA to be by itself. And I'm going to move everything else. I'm basically moving the right-hand side to the left side, left-hand side to the right side. Okay, so, and so let's see here. So we've got PATM plus, well, let's see here. S1 is 0.7, 0.7. I'm going to, you know what I'm going to do? I'm going to pull that gamma water out. Yeah, let's go ahead and pull that gamma water out because all these terms have a gamma water in them, right? So the gamma of water is 62.4 pounds per cubic foot. Now, how did I know pounds per cubic foot and not newtons per meter cubed? Well, because this is in inches, right? So we're going to keep track of, because we're in the English system of units. Okay, so now we're left with, let's see here, S1, so that's 0.7 times H1, which is 1 inch, but I want it in feet because we've got a feet right here. Okay, and then I'm going to go plus S2, 0.8 times H2. So H2, we've gone down 1 inch, so 1 over 12 feet. Okay, plus S3, so now we're in this third layer here, and S3 is 0.9 times gamma of water. Gamma of water has been removed, and the H3 is 1 over 12. And then the S4, which is 1.0, which I kind of don't even need to write, right? And then H4, we only go down 1/2 of an inch. So that's going to be 1/2 over 12. Yeah, sorry. This thing did some weird stuff to me. Or if you prefer, 1 over 24. Okay, so this is 1/24 of a foot. Okay. And so now we've got it all. Okay, so PA equals PATM, okay, plus, okay, and I'm gonna keep this all separated out into individual terms, but notice I've got PCF being pounds per cubic foot being multiplied by feet, so PCF being multiplied by feet, so that's gonna be pounds per square inch. So I'm gonna end up with, I'm gonna distribute this 62.4, I'm gonna get 3.64 pounds per square feet plus 4.16 pounds per square feet plus 4.68 pounds per square feet plus 2.6 pounds per square feet. Okay, so notice that as the, each inch that you go down in a more dense fluid, okay, we get more pressure increase, right? So for each inch, which makes sense, it's a denser fluid. Okay, now this one we only go down 1/2 an inch. So, if we'd gone down the full inch, we would have gotten, a larger number than 4.68. Okay, so PA then equals PATM plus 15.08 pounds per square feet. Okay, if we plug all that into our calculator. Okay, so now this is where we're gonna think about our gauge versus our absolute. Is really, it only really comes down to what is the pressure in the atmosphere. Okay, and so I'm gonna split it in 2 ways. Okay, with the difference being over here PATM equals 0 gauge, and over here PATM equals it needs to equal something, right? So considering we're in the English system, typically it's 14.7 PSIA, okay, absolute. Okay, or if you wanted to, we can convert that by multiplying by 144, and we get 216.8 PSFA. Okay, so we're going to do that, noting that all we're saying here is that the pressure at A is 15.08 PSF higher than the pressure in the atmosphere. Okay, so if we plug in zero gauge, then PA equals 0 plus 15.08 PSF. Okay, and so we say PA equals 15.08 PSFG. Okay, and the G is usually understood. Okay, that's kind of like a pretty standard way to do this. We'll do the same thing over here. PA equals, but instead of plugging in 0, we're going to plug in 2116.8 PSF absolute. Okay, and then I'm going to add that 15.08 PSF, right? And so we're going to get PA equals, let's see here, 2131.9 PSF absolute. Okay, and that's typically how we write this. Okay, so we're not done because I want you to keep at least 5 significant digits throughout your calculations, but I want you to report the answer in so PA in with only 3. So over here it's well, you know what? Before we do that, let's go ahead and get these in PSI, because sometimes people prefer that. Okay, so we're going to divide this by 144, and we're going to get 0.10472 PSI gauge. And over here, I'm going to divide by 144, and I'm going to get 14.805 PSIA. Okay, so notice this is just a little bit higher than atmosphere. Okay, and over here, this is just a little bit higher than atmosphere, the same amount higher than atmosphere. Okay, so so your final answer, we want 3 significant digits. So let's go back to black, and we'll say PA equals 15.1 PSFG, which equals 0.105 PSIG. Okay, and over here we'll say PA equals, we could actually do an equals for all of this, because all of these things mean the same thing, equals 2130, 3 significant digits. PSFA equals 14.8 PSIA. Okay, 3 significant digits. Okay. Anyway, that's your answer. That's your solution. That's how we solve this. Okay, so hopefully that helped you. 13 minutes. So I don't think this one's really too bad. Okay, thanks, guys. Let me know if you need anything else. Okay, take care of yourselves. Remember, fluids is important. You're more important. All right, take it easy. Bye. Or